Q3. Yeah, number of subsequences that satisfy the given sum condition. So this one is actually, I did like this problem. It's a little bit tricky, but it's still, I dig it. And basically the problem for this problem, yeah, there are a couple of ways to think about it. The way that I thought about it is that, for example, well, first of all, you sort because why not sort? And it's, for n is equal to 10 to the fifth, sorting will be fast enough. But let's say after you sort, then you want it to have some target that it is smaller than, right? Well, now you're going from left to right. Let's say the answer is, I think in this case it's, okay, 12 is a little bit big, but maybe that's fine. Let's just say this is 9, right? Well, for 2, then you do a binary search for the number that is, that lets you do, you find the index so that the sum between that number and the target is less than this. So in this case, it'll be 2 to the 7. And the way that I structure is that I am forced to have a 2, right? So now that means that all these other numbers are free in that it could be 0 or 1, right? So because you only care about the max, and you know that the max will be 7 in this case, and any number that's smaller than 7, let's say you have a subset. So if both 2 and 7 are in the subset, then you know that the target is, the sum is going to be equal to 9 of the max and the min. But let's say it's less than 7, right? Let's say your sequence is, this, right? Then, well, this, that this is going to, the sum between the min and the max, and it's just going to be 6, which is smaller than the target, because this max number is already going to be bigger than that number. So in that way, the size, the length of this sequence, without the 2, every number could be just, it could be 0. When I say 0 or 1, I mean like every number in here could be in the set or not in the set. And because in this case there's 5 numbers, so that means that there's just 2 to the 5th case. Oops, 2 to the 5th case where, so there's 2 to the 5th case where this is true. The thing that I handle a little bit differently, or you have to be careful about, is that, well, if these cannot all be not in the set, because if these are all not in the set, then you have to look at the first number twice. And then I handle that. So we subtract 1. This is why I have to subtract 1 here. I subtract 1 so that it doesn't count the case where they're all not in the set. And then I do a separate check, which is, if 2 times 2 is less than target, then I add that set back in. So that's how I do the summing. And I do a mod. And in your language, you have to do a mod pow, a power that's mod, and that will make it a lot easier. And then you just kind of keep on going as you go left. So for example, in 3, well, you do a binary search, and the binary search should tell you that it's actually, 6 should be good. And actually, now that I think about it, you actually don't even need the binary search. You know that it converges, from left to right. So you could have just a right pointer that goes from right up. So yeah, but binary search allows you to kind of think about it without worrying about certain things. That's how I thought about it. But yeah, but you can actually just move. You can have 2 pointers that starts, at both endpoints, and then move slowly toward the middle to make sure that the invariant is that the sum is less than 9. I actually didn't think about that, but until just now. So whoops. But binary search also runs in time. It's n log n. But if you actually did it now with this linear algorithm, then it'll be O of n, because every element will be on the left side or the right side only once, right? And yeah, and once you go past the middle, you just have to check, the target, the number times 2, and that's pretty much how this algorithm works. And yeah, so you could do it in n log n if you did it like I did with binary search, but as we actually discovered together, you can actually go from right to left, so it's O of n. So this makes it an O of n algorithm, which is fast enough. And yeah, oh, sorry, I forgot about the sorting. So you do have to sort, so it is going to be n log n plus the O of n. So I guess in that sense it doesn't really matter, but it is still O of n log n. But if the array is sorted, then you just go left to right, right? So, and right to left. So that'll be still faster for that reason. For For space, it is you could see that we don't use any extra space or like we use constant amount of extra space with some caveat around sorting in your native language. So yeah, but mostly all of one say, right? Extra space. So that's kind of Q3 number of subsequences that satisfy given some condition.